Okay, so let's talk about what happens when we have too much water. Okay, so the Brisbane Flood of 2011, there was a massive flood, and we're going to have a quick talk about why it happened and the human factors involved in that, and the repercussions. So let's talk about what actually happened. So this is some information, you can read it, but fundamentally what was important about this was that there had been a culmination of events. It wasn't just a one-off thing, it wasn't just something that happened, it was a range of sequencing of events that meant that this massive flood occurred in Brisbane. So one of the points I want to talk about here is that because it had already been quite wet, it meant that the catchments, i.e. the dams, and we've talked about dams and how we capture water for people to drink, were already basically full and the ground was saturated. So what that means is when the rain falls, it's not seeping in to the ground and the ground's not absorbing the water, it's actually just doing straight runoff. And also there were human choices about this in relation to when to release water from the dam to release pressure. So let's have a quick look at what the dams are in Brisbane. So you can see this is all the Brisbane River that flows through here. And what they've done is in order to get enough drinking water to supply Brisbane, they've actually created two dams back here. And so they've dammed the Brisbane River, and we've talked about that and how we capture water. And then what they do is that then they release water into the Brisbane River when the dams get too full. Otherwise, they pump the water through there into treatment plants and then it feeds the greater Brisbane area. All right, so the choices that we made by humans in relation to this was setting up these two dams above Brisbane on the Brisbane River to catch water for them to drink. Now let's talk about what actually happened with the dam. So when people build dams, then water is flowing in and water has to flow out. And the water can only flow out into the treatment plants and things like that at a certain rate. When that rate, when the water coming in starts to exceeds the water going out, what they do is they release the water through other means, and they do quite a large release. You may have been to Scrivener Dam and seen them releasing water into the Cotter River when the lake gets too full. So the same thing happens here. So Lake Burley Griffin gets too full, Scrivener Dam actually opens and they actually drop those walls. They actually just slowly move down and the water comes over the top. You may have seen it. So the same sort of thing happens here. So here you can see the dam flowing out. So the water flowing out is the light blue line and the water flowing in is the dark blue line. So you can see here on the 2nd of January, it's quite low, but then this is when the rains start. Then there's this massive rain downpour here and another one here. And this is when they decided that they had to release the water. And this is because this red line, is called the headwater elevation. And what that actually means is how much pressure is sitting against that dam. So if you think about it, it's exactly like, if you've got a piece of paper and you start putting water against it, it'll hold until the point where it doesn't. Concrete's exactly the same, and if it breaks, it's massively bad. So we need to be conscious of that. So this is the pressure building. So you can see here, this is the pressure building against the dam, and here it peaks. This is where they start to release all the water and the pressure starts to drop. Okay, and then they release more pressure here. But the flood happens on this day here. All right, so why did it happen? Well, one of the problems is that, and as social scientists, it's really important, and this is one of the reasons why I keep talking to you about what's your evidence, what's your data, where's your analysis and your information, is that one of the things that happened was they were unsure of the data that they were receiving about how much rainfall was actually happening and how much was actually forecast. So the dam itself had problems about rain gauges, and they weren't quite accurate enough in relation to the data they were collecting, but then also the forecasts weren't quite right. And you can see here, the forecast is the light purple and the actual is the maroon. And here on the 7th of January, they forecast that much rain, and this was actually the rain that fell. But then here on the 9th, they forecast a lot of rain and not a lot of rain fell. So you can see here that but we know this anyway, when we hear the forecast in the morning, it's not always accurate because it's a guessing process. Okay, and that becomes a problem because then that means you have to use judgment and analysis and patterns of the past to try and work out what's going on and what might happen in the future. Then the question is well, could they have known this was going to happen? And the answer is yes, because in 1974, a very similar thing sort of happened. You can see here, this is the normal waterways that you can see, but the red line is the 1974 floods and the blue line is the 2011 floods. So the areas where these houses and infrastructure are had already been flooded in 1974. Okay, so if you think back, 18,000 places were inundated, that means they were covered in water. Then why did they rebuild in areas where the flood has already happened previously? So they could have known, they did know because it happened in 1974. So it becomes an interesting question of, well, why do they keep building where things keep flooding? And here's an example of actually what happened with the flooding. So here's a normal area at the side of the river, and this is what it looked like when it was flooded. Again, look at all this infrastructure here, so all these buildings, and then it completely flooded under like that. So all these homes here, and all of this, I'm assuming factory or storage areas here. All right, so all of this is costly. So if we think back to the United Nations Sustainable Development Goals and the economic costs, the hazard costs of water, this is a hazard cost of water, is this flooding. I wanted to show you that I use sources for this because this is actually quite detailed and I'm not overly familiar with the content. So I use this source here and I use this source here, and you can see here I've done Harvard style because I've got the author's name, then I've got the name of it, the name of the page, and then I've got the URL and then the date last viewed. This URL just isn't in blue, and that's okay. And you can see here it's in alphabetical order. So this begins with V, that begins with W, so I'm in alphabetical order. Okay, so that's the Brisbane floods.